Good morning, class. So let's continue to discuss the third group of measures for descriptive statistics. These are the measures of shapes. Okay, now for the first measure, we have your skewness. So skewness actually describes the lack of symmetry of the data. Thus, the coefficient of skewness measures the degree of asymmetry of observations around the mean, which is computed, okay, using the following formula. So, skewness is equal to n times the summation of the cube of 1 or x sub I minus x bar all over the cube of the standard deviation times n minus 1 times n minus 2. Now, skewness has different shapes, okay? If we have a perfect symmetry wherein skewness is equal to 0, the orange figure is actually the shape of our distribution, okay? The skewness is 0. That is because if we are going to half, okay, the figure, the left side is the same as the right side. That's why the skewness is 0. If your skewness is actually positive, ibig sabihin, ang tinitingnan kasi natin dito, let's say, the peak, okay, this part, okay, if we're going to draw the line here, this is actually the mean. Okay? This is actually the mean. Okay? And then, tipang kitaan tayo ti skewness kat deja agsalog. Okay? So, if the skewness is to the right side, or if the figure is skewed to the right side, okay, we have positive skewness. Okay? But if it is skewed to the left side, okay, then that is negative skewness. Now, we have degrees of skewness here. If we have high degree of skewness, if skewness is equal or greater than 1, then we have high positive skewness. If your skewness is less than negative 1, we have high negative skewness. If your skewness is between 0.5 and positive 1, we have moderate positive skewness. If your skewness is between negative 0.5 and negative 1, then we have moderate negative skewness. If the value of your skewness is between 0 and 0.5, we have relatively positive symmetry. Kumbaga, basit laang DJ skewed portion. And then, if your skewness is between 0 and negative 5, then, or negative 0.5, I should say, then we have relatively negative symmetry. So, these are actually the classification of our skewness, how we're going to interpret our skewness. Okay, now to explain this so that you will be able to understand, let's look at our Excel. Okay, so in our Excel, okay, we have your deviation, etong part na to. Okay, so x sub I minus x bar. So, remember, these are actually, or this is already computed in your standard deviation. Correct? So, eto siya. Okay. So, I'll just change it. Okay, there you have it. Now, remember, we need our standard deviation here. That's why we need to compute for the sample variance, and then we get the square root. Now, using the formula of our skewness, all we need to do is to raise to 3 or third power yung ating x sub I minus x bar. Ito. So, how to do that? We have equal sign and then the cell raised to 3. Okay? So, enter. Ayan. So, all we need to do is to copy. Oops. Okay. Okay, so kopyahin lang natin and then there you have it. Okay, so I'll just change the format into number so that you will be able to see. There you have it. And then we get the summation. Okay. Yan. And then n, we have 12. Okay. So n is 12. Our standard deviation is 95,000. So I'll just copy. Okay. And then n minus 1, we have 11. And then we have 10. Then all we need to do is to get our skewness. Okay. So we have equal sign. So the first term, etong nasa tuktok, we have n times the summation of x sub I minus x bar raised to the third power. Okay. Divide by, okay, we have your s cube. Okay. Take note, we need to have the cube of your s. Okay. So, s, okay, I'll just change it. So, papalitan na lang natin ito. We have your standard deviation. Okay, your standard deviation raised to 3. Okay? Yan, para mas madali na siya. So, again, we repeat the process. We have equal sign. N times this one. Divide by the cube of your standard deviation. Okay? Multiplied by 11. Multiplied by 10. So, we have 1.36. Now, if we're going to look at the interpretation of 1.36, ibig sabihin, we have positive skewness. Okay? Based from our interpretation. So, let's get back to our PowerPoint. Okay? For the interpretation. So, tingnan natin. We have 1.36. So, our data is highly skewed. Okay? Or high positive skewness. Okay? So, tingnan natin. So, i-check muna natin using our Excel formula. We have skew. Okay? Since we are dealing with the sample, hindi na natin kailangan lagyan ng point S. So, skew and then this one, the data range. So, we have 1.36. So, high positive skewness ito or positively high or highly or high positive skewness. Okay. So, i-check natin kung ano yung kwan natin, yung skewness niya, kung mataas ba talaga siya. So, let's try to make our frequency distribution. Okay. So, tingnan natin. So, let's say we have 5 groups. So, 1, 2, 3, 4, 5. So, for upper limit, okay, or sorry, this is lower limit and then your upper limit. Okay. So, in the first category, the lower limit will be the minimum value. Okay? The minimum value of our data. Okay. And then the upper limit will be the maximum value of our data. Okay, so we compute for the range. Okay, so we have range, we have your maximum minus minimum, and then we have your bin. Okay, so we have 5. So this will now be the bin width. Okay, so we have 3 divided by 5. So it's 69,650. So we just add here plus ito. Okay, so copy paste ko lang siya. Okay, so i-check natin kung wala siyang decimal point. Okay, so wala siyang decimal point, so pwede natin gawin the upper limit plus 1. Okay? So, yan. So, there you have it. So, if we're going to check whether we have the same width, so, ganun lang kasimple. Okay. Now, dito, makikita ninyo, 69,464. Mas mababa siya compare dito sa 4. Kasi, we can actually extend this by adding 4. So, maging 254. But since this will now be the last data, so dito na siya papasok. So, okay lang yon, walang problema. Okay? So, then we have your frequency. Frequency. Okay? Ayan. So, titingnan natin. Equal sign. Frequency, okay, our data value or data range, comma, the bin, which is the upper part. Okay, and then control enter. So we check, okay, if we have 12 data. So there you have it. Okay, now next we make our histogram. So, punta tayo dito sa data. I hope you still recall this. Data analysis. Okay. So, we create our histogram. So, ano yung input range natin? That will be your data range. Okay. And then, our bin range, yung upper limit ng bin. Okay. Next. So, walang label. So, maglalagay tayo ng output range. So, saan natin siya ilalagay? So, somewhere here. Dito sa part na to. Okay? So, dito. Yan. And then, our chart. Okay? Chart output. So, hindi tayo magpapareto. So, okay lang yan. Okay. So, you will notice, ito yung ating histogram. Okay, ayusin ko lang. Tanggalin ko na lang yan. So, we have this. So, liitan lang natin. Okay. So, liliitan lang natin para magkasya. Yan. Okay, so, hilahin ko pa ng konti. Yan. So, makikita natin asaan yung mean. The mean is 937. So, 220. So, more or less, yung mean nandito siya. Okay? Dito sa part na to. So, magdodraw ako ng line para makita ninyo yung shape niya. So, more or less, yung mean nandito sa part na to. Okay? So, gawin lang natin siyang outline or broken line. Yan. So, andito yung mean. So, if we are going to draw the figure, okay, so from this point, pataas siya bigla. Okay. Yan. So, parang ganyan yung kanyang shape. Okay? So, it actually sloped down. Okay? Kasi bumaba na siya dito. So, totally pababa na yan. Okay? So, yan yung ating skewness. So, based from the histogram, makikita natin na skewed to the right or highly skewed to the right. Okay? So, positive skewness siya. So, that is all about skewness. Okay? Now, let's talk about the other measure, and that is your kurtosis. Okay. So, kurtosis is all about the tails of the distribution, not the peakedness or flatness of your data, okay, or the distribution. This is actually used to describe the extreme values in one versus the other tail. Okay? It is actually the measure of outliers present in the distribution. So, this is actually the formula. So, medyo mas mahaba siya. Okay? So, let's look at the different types of shapes here. If your kurtosis is less than positive 3, then we can consider it as platykurtic. Okay? If your kurtosis is equal to 3, etong black, this is mesocortic. And if your kurtosis is greater than 3, then we have leptocortic. Okay? So, sasabihin nyo lang ng ganon. So, let's go back to our example dito. So, having the same data, di ba, ang gamit, ang kwan natin dito is yung 4. Okay? Raised to the 4th power naman, pati yung S natin. So, all we need to do is to get yung x of I minus x bar nyo, we raise it to 4. Okay? So, ayan. So, medyo mataas na siya. Ka-copy-paste lang natin. And then, we get the sum. There. And then, for the standard deviation, i-raise din natin siya into 4. So, we have 12 na n. We have 13 here. N plus 1. 11, 10, 9. So, for the kurtosis, we have n. Okay, we have your n times n plus 1 times the summation. Ito. Okay? Yan. Divide by, okay, the quantity n minus 1 times n minus 2 times n minus 3 times the square, that's the standard deviation, which was raised to 4. Okay? Yan. So, lalagyan ko pa ng isang parenthesis dyan. Minus, we have 3 times, okay, the quantity 3 times yung n minus 1 raised to 2. Okay? Etong 11 raised to 2. Okay? Divide by the quantity n minus 2 times n minus 3. Okay. So, tingnan natin kung correct yung ating makukuha. So, we have 2.61. So, going back to our example, in our PowerPoint, or in the figure, yan. So, 2.61. So, mas mababa siya sa 3. So, we can say that the distribution is platykurtic. Okay? Platykurtic siya. Kasi, mas, tawag nito, spread yung ating data. Kaya siya mababa. Okay? So, yun yung ating skewness. Now, going back, a high kurtosis in a dataset is an indicator that the data has heavy tails or outlier. Ito daw, itong pinakamataas, okay? If there is high kurtosis, then we need to investigate why do we have so many outliers. So, I think I already discussed to you how to identify your outliers, okay? It indicates a lot of things, maybe wrong data entry or other things. So, you need to investigate. Okay? Now, if we have low kurtosis in the data set, it is an indicator that the data has light tail or lack of outliers. So, dahil yung na-compute natin is 2.61 na kurtosis, okay? Ibig sabihin, wala tayong outlier. So, still recall, when we computed your z-scores, walang lumabas na 3 or greater than 3. So, pwede natin sabihin na wala siyang outlier. If we get low kurtosis or too good to be true, then also we need to investigate and trim the dataset of unwanted result if in case you have suspect or if you suspect that there is or there are something wrong with the dataset. Now, as I have said a while ago, the z-score can be used to determine your outlier. So, leptocortic, going back, leptocortic, wherein your kurtosis is greater than 3, the distribution is longer and tail are fatter. Okay? Peak is higher and sharper than mesocortic, which means that data are heavy-tailed or profusion of outliers. Outliers is stretch the horizontal axis of the histogram graph, which makes the bulk of data appear in a narrow, skinny, vertical range. So, makikita nyo dito. Okay? Thereby giving skinniness of a leptocortic distribution. Now, a mesocortic, itong pangalawa, has kurtosis static similar to that of a normal distribution. This means that the extreme values of the distribution are similar to that of a normal distribution characteristic. This definition is used so that the standard normal distribution has a kurtosis of 3. Now, the last type will be your platycortic, wherein your kurtosis is less than 3. So, distribution is shorter, tails are thinner than the normal distribution. Okay? The peak is lower and broader than mesocortic, which means that data are light-tailed or lack of outliers. The reason for this is because the extreme values are less than that of a normal distribution. So, that is all about our kurtosis. By the way, going back to Excel, you can actually use also your Excel function to check your kurtosis using your KURT, okay, and then yung inyong data set. Okay, so check lang natin. So we have 2.61, so tama. So we have a platycortic distribution. So that is an indication that we don't have any outliers. Okay, so that is all about the measures of shape. Okay, so if you have questions, feel free to message me through our group chat. And in our next video lecture, we're now going to discuss measures of association. Okay, so God bless, stay safe, see you in our next video lecture.